Hello again, AP Stats. This is Mrs. Harding. We are going to do our very last video for Chapter 2. Hopefully this one is a quick one. You can find the activity that goes along with this, Lesson 2.2c, in your Class 1 note. So far, we've been talking a lot about a normal distribution. It's an incredibly useful distribution. There's a lot of information that you can get about it. And so what we're going to talk about here to wrap up Chapter 2 is how to assess whether a distribution is actually normal. And you can see that lesson objective at the top of the screen: determine whether a distribution of data is approximately normal from graphical and numerical evidence. So one of the things that we can look at is we can look at what the distribution actually looks like. So in the example at the top of the activity is, suppose you flip a coin 10 times and you keep track of the number of times you get heads. And then you repeat this 150 times. So let's take a look at that data. So here in the table, there was one time that they got 1 out of 10 heads. 7 times it happened that they got 2 of the 10 came up heads. 18 times there were 3 heads out of 10 flips, and so on. Not unexpectedly, the most common was to get 5 heads out of 10 flips. So one of the things that we can do is look at the shape of the histogram and figure out if it appears normal or not. So you can put those into your calculator. I can show you. Edit. Put the values into L1, and then remember you can put the frequencies into L2. Hit second, y equals. Turn plot 1 on. Make sure you select the histogram. Our data is in L1. The frequency is in L2. Hit zoom 9. Does it seem normal? It does. It's unimodal. It's symmetric. It's approximately normal. So maybe a normal approximation would be a good fit for this. What you could also do, which would be a little bit more time consuming but is a little bit more definite, is you could see how closely this fits the empirical rule. So you could go through and figure out what the mean is, what the standard deviation is, and then determine how much of the data falls within 1 standard deviation, how much of the data falls within 2 standard deviations, how much of the data falls within 3 standard deviations. So in that way, by showing that it fits the empirical rule, you could also show that a normal approximation would be accurate. But there's actually another type of display that you need to know about called a normal probability plot. So if you just flip to the next page there, this is a specialized graph whose purpose is to help you determine the normality of a set of data. And this is actually pretty helpful when you have a smaller data set. When you have a larger data set and you can clearly see the shape of the distribution, looking at the graph can give you the information that you need. But sometimes for smaller data sets, you want to just be sure that it's normal. So if you look at the data that's listed there at the second page, 1, 2, 2, 3, 3, 3, 4, 4, 5, and you can make a dot plot of it. It looks unimodal, somewhat symmetric, but there's really not that many numbers, so it's hard to say for sure. Now, in a normal probability plot, there is a way to obviously determine this by hand. That is not expected of you as part of this course. We're just going to expect you to be able to create one on your calculator and interpret it. So let's use this data here, and I'll show you how to set up a normal probability plot. So what you're going to do is put the data into your calculator, which I've done already, if you want to take a moment and put that in. If we look at the histogram, it will look like the dot plot that you see on the answer key. And again, it looks unimodal, symmetric. It looks like it could be normal, but with such a small data set, you want to know for sure. So the way that you go to plot a normal probability plot is you enter your data, go back to stat plot, so second, y equals, go to this first plot, and this time you're going to select the very last one in the list. That's the normal probability plot. Now you can see one disadvantage of this is that we've lost the ability to put in a frequency list. So if you were going to make a normal probability plot for something like our first example, it might be pretty tedious to enter all of that data into list 1. So in this screen, the data is in list 1. The data axis is X, just leave that as it is. You can select whichever type of mark you would like. And then you're going to hit zoom and then 9. And here's what you're looking for. The way that you want to try to interpret this is you're looking to see how linear the normal probability plot is. Do these dots fall relatively in a line? And you can see that the graph is fairly linear. So if the normal probability plot appears linear, then the data is approximately normal. So based on this plot, we would say yes, that it is an approximately normal data set. So why don't we take a look at a different one? Step number 3 at the bottom of the second page is a new data list. So I'll put that in here. I'm going to go in and just clear, enter out the whole list. And there are 4 ones. But again, if I'm going to do a normal probability plot, I cannot use a frequency list. So I have to enter in each of these numbers. There's 1 3, 2 4s, and 4 5s. 1, 2, 3, 4. So this is the data list. If I go to take a look at the normal probability plot for this one, let's double check again how to do that. It's on. I've selected the normal probability plot here at the end. The data list is in L1 and so on. So if I hit zoom 9, does that look relatively linear? And the answer is no. We have all these clusters of data points. So because this normal probability plot is not linear, we would assume that this is not a normal distribution. And in fact, if you went back and created the histogram for this, I will leave that up to you, you will see that it's not even close. So when it comes to assessing normality, the very first thing that you always want to do is to look at the distribution of the data, the histogram, the dot plot, the stem and leaf, whatever it might be. If the distribution is unimodal and roughly symmetric, then you can look at the normal probability plot to see whether or not it's linear. If it's linear, this confirms that it's normal. If it's not linear, it tells you that it is not normal. However, your first step always is to look at the distribution itself. And that is it for Chapter 2. As always, if you have questions, please ask Mr. Bowman or myself.